Okay, so previously when we were doing the sine law, right, the key is you could use the sine law. It was really quite easy, right? You just cross multiplied. Is that correct? Okay, now look at this question up here. Look at the first example up here. In here, we have two angles and a side. Well, we had that with the sine law, didn't we? We had two sides and an angle, didn't we? Why can we not use the sine law in this case? Take a wild guess. Okay, so the 175 and the 160, do they have angles across from them? Do we know angle B across from the 175? No. What about the 160? Do we know angle C? Oh, okay. So the only angle we know is 55, and that's the side we're looking for. So if we actually use the sine law, we wouldn't have one unknown, we'd have two unknowns. Can't use it. Oh, that sucks. Okay. So we have something called the cosine law. It's a different formula. Now, do you have to memorize this formula? No, it's on your sheet. You got to know how to use it. And there's two basic patterns for the cosine law. One of them is if it starts with a small letter, guess what you're looking for? A side. If it says cosine of A, B, or C, or whatever letter it is, and it's a capital, you're looking for a angle. That's the simplest thing. So whether you're looking for a side or looking for an angle, you're going to use either the formulas on the left or the formulas on the right. Now, I don't know if, but you might actually notice a pattern here. Look at this first one. What does this letter start with here? An A, so what angle's right at the end of it here? An A. What's in here? A B and a C. What two letters are in here beside the two? B and C. Okay. Now look here, the second one. What letter is here? A B, so what angle? B and C. What two letters are in here? A and C. And what two letters are in here? A and C. Do you see how the pattern's there? Are you always going to get A, B, C's? No, you could get X, Y, Z's, couldn't you? Pattern's still the same. Look at the angles now, if you're trying to find an angle. If you're looking for an A, what do you notice is the last letter here? A, and then the other two letters are B and C and B and C. Now, basically, guys, those formulas are the exact same thing. They're just rearranged. Right? This is just algebra. Right? For instance, if you start moving things around in here, if you move the A squared over to this side, what does it become? Negative A squared. Oh, okay. And then you divide by, where are we here? Oh, cos of A, right? You divide cos of A, it's on the other side. All they are rearranged. You don't have to worry about that. Pick one, pick the other. Okay. The easiest way to show this is to show by example. So we're going to do two examples. One, we're going to find a side. One, we're going to find an angle. Easy peasy? Now, after that, you can do whatever you want. You can use sine law to find other stuff. Okay, let's do the question here. Okay. Find the length marked A in the triangle. Oh, well, that's the example we're going to do. So what are we looking for? A length or an angle? We're looking for a length. So this is going to be the really long formula on one line. Is that correct? Because we're looking for a side. What side are we looking for? A. So what letter am I going to... Oh, you know what? Before I even do that, before I even write down the formula, what should I do with this triangle? Label it, please. Okay, 160 is... What side is that? Little c. B is the 175. A is 55, and that's A there. Oh, yeah, that makes sense. Okay, now I'm looking for little a. So what is my formula? What does it start with? A squared. Hey, if we start with A, what are the next two letters after that? B and C. Doesn't matter the order? No. B and C. Now that should look familiar, that first part. What is that, by the way? It's a variation on Pythagorean theorem. Basically what you're doing with the cosine law is you're taking that triangle and cutting it into two right-angle triangles. That's where that's all coming from. Minus 2, oh shoot, I can't remember the letters. Where are they? What letters are here? B and C, so what letters are here? B and C, and then the cos of, what does it start with? A, so then it's the cos of A. Right? Once you know the pattern, the formula is really easy to use. Okay, now what do? Take everything and plug it in. There we go. So A squared, A, what's B? 175 squared. C is 160 squared minus 2 times 175 times 160 times the cosine of 55. Okay, now, here's your thing. Stop. I'm going to show you where your most common mistake is. And I guarantee you, like 50% of you will make this mistake. At least. Ready? Oh, yeah. funny because like grade 12 they do the exact same thing. We just learned this formula. Now, if you look at this, look at all this calculation here. What rules are we taking into play here? What's it called? Bedmass. You got to remember your rules of bedmass. So brackets, exponents. So anything with exponents. So this 175 squared, should it be done first? What about this 160 squared? Should it be done first? And look at all this. Is all of this multiplication here this back end? Okay? And what separates these two things? Addition and subtraction. So what's the last two things you're going to do? Add and subtract. This is my recommendation to you in doing this to keep it organized. Do the 175 squared, do the 160 squared, do all this multiplication. So the next line that you're going to write is going to have 3 numbers in it. What the mistake that students make all the time is they add all this together, and then they subtract this, and then they times it by cos of 55. I see it all the time. They mix up this last step here. Okay, so let's do some math here now. Okay, so a squared, I need some room here. What's 175 squared? 30625. 160 squared is 25600 minus 32120.2804. Guys, don't round until the last part. Keep that number in your calculator if you want. Don't do any rounding until you're actually at your last final answer. And if you got that, if you didn't get the 32120.28, make sure your calculator's in degrees, please. And make sure you actually press cosine and not sine. Very common mistake. Which one? Cos of 55. Type it in your calculator. Times 160 equals. Times 170 equals. Times 2. What'd you get? Is your calculator in degrees? Cos of 55 equals. Yep. Yep. Do you see though? I mean, you know what you're doing math-wise, and you were getting that wrong, right? This is where you will screw up. This last part, I guarantee you, this is where the screw-up comes from. Okay, so you add this plus this minus this, what do you get? 24104.71956, right? A whole bunch of junk. Wow, that's a really long side. Since the other sides are 175 and 160, that doesn't make any sense why that side is so much bigger. You got to take the what? Square root, right? You got to take the square root of it. It's a squared, guys. What's the opposite of squaring something? Taking the square root. You got to do that on both sides. Don't forget that. That's your last. So a equals, and what's the number? 155.3. If you go to one decimal place, right now you can do your rounding. And does that make sense? Look at the actual triangle. Does that make sense? Because this is the biggest side. That's probably the biggest angle. This one should be less than that. Yeah, that makes sense. You should be able to tell from your answer whether you're in the ballpark or not. I mean, it looks complicated, but it's really, is it quite an easy formula? Yeah, it's not bad. It's just a matter of really keeping it organized when you put in all the numbers. Okay, that one's for the side. Guess what we're going to do now? Angle, of course. Okay. Find the measure of angle R. Now, this is not ABCs, but guess what? Is the pattern still the same? Yes, it is. Now, we're looking for an angle, so this is the one with the numerator and the denominator, but we treat it exactly the same way. There's a triangle. What's the first thing we should do? Label it. What's this 9.1? Little w. What's this 8.8? Little r. And what's the 8.5? Little t. What are we looking for? Angle r. So we're looking for the cosine of r. Now, you know right away, what letter did we start with here? So that's the one we're going to subtract at the end, isn't it? Isn't that correct? Okay. And what two letters go in here? T and W. And what two letters go on the bottom? T and W. Oh, cool. So T squared plus W squared, right, minus that R squared. And what's on the bottom? 2 TW. Now, do you see the steps there that I did in creating the formula? I looked at my angle, and then the second thing I did was put my R at the end, right? Because I know it subtracts that one. And then the other ones are just filling in the T's and W's. There's our formula. Now what do we do? Take everything and plug it in. Okay, plug it in. So cos of R is, oops, I can't even see the board. T is 8.5 squared plus what's W? 9.1 squared minus 8.8 squared all over 2 times 8.5, 9.1. Basically, guys, when you do the math, do all the top, do all the bottom, then do your division, right? Do all the top, do all the bottom, then do your division. Easiest way to keep it organized. Let's see if you get the same numbers once we get done there. You have to do the math anyways, no matter what. I always try to teach that because if I tell you that enough times, you'll remember it. What did you do, Ron? Ow. So add this. What's that? What's that? That's correct. Don't add that. Careful. Watch your signs. Okay, did you get 0.5017? Did you get that? You didn't get that? Oh, not as your fun. I was going to say, well, that's kind of a stupid looking angle, isn't it? 0.5017. Guys, you know this. You know this rule. When you need to find an angle, what's the last thing you do? The inverse of it. So in this case, now careful. I see this one too. People are so used to using the sine law, they don't use the inverse cos, they use the inverse sine. I see it all the time. Again, make sure you're using the inverse cos. Okay, so if we want to find angle R, right, we want to take the inverse cos of whatever that number is, 0.5017, ... And we find out angle R is 69.9, which rounds to the nearest degree, 60 degrees. And now, does that make sense? Like, look at the picture. Yeah, that's good. Plus, between 0 and 90, makes sense. Cosine is just another tool, right? You have to decide when you're doing these questions, eventually, when you get a question, a trig question, which one do I use? Do I use sine law or do I use cosine law? Well, it's easy to tell. If you have a side across from an angle, right? You have an angle and you have a side. You have a side across from an angle. Which one can you use? Sine law, right? If you have nothing across from that angle or that side, which one do you have to use? Cosine. Oh, that's it. Now look at that one. That had 3 sides. Were there any angles at all? No. So you have to use cosine law, right? That's how you think about it, right? If there is a side across from an angle, use the sine. Oh, actually, side across from the angle, sine. Sine across from the angle, sine. Does that make sense? I'm just trying to give you a method to remember. Okay, I'll give you the questions in a sec of which ones I want you to do.